Hello, I am Zane Motter, and this is my final project for Physics 1550 at Lakeland Everyday Physics. And it is explaining how a bicycle functions using the gyroscopic effect from physics. This is a bicycle, and the bicycle has two wheels which are both in a line. And so these wheels are unable to support each other, and so the bicycle has to balance. And so when you leave it alone, it will always try to fall over. Unless, however, the bicycle is moving. As I ride the bicycle, it is able to stand by itself and resist falling over by taking advantage of the gyroscopic effect. As you saw there, the bike was able to stand by itself for a short period of time while moving. However, as it slowed down, the gyroscopic effect got weaker, and causing the bike to fall over. However, the gyroscopic principle is not limited to just the bicycle. It in fact is only used in one component of the bicycle, which is the wheel. The wheel itself can be used to demonstrate the gyroscopic effect. As long as it's moving, the wheel is able to self-balance using the gyroscopic effect, just like a bicycle. The simplest way to describe gyroscopic force would be an object maintaining its own angular momentum. What this basically means is that it is able to prevent itself from falling by catching itself within its own fall. The simplest example I can come up with to demonstrate how it's almost preventing itself by catching its own fall is with this globe. Now this globe is just like our Earth, and it rotates around its own center of gravity. And so, if you are this clone, and you're on a point of it, and it rotates, you will be moved, but you will be in the same location based off the globe. However, imagine an alternate reality where the Earth rotates around you. So, if it's rotating slowly, it's above you and a force knocks you off, you will just fall. However, if it's going fast enough, just like if the wheel is going fast enough, as it rotates and you begin to fall, you won't fall into the outer space, because the Earth will be below you and it'll catch you, because you won't fall fast enough if it's able to be below you already by spinning. It's spinning quick enough. However, if it's spinning too slowly, then you can fall out. The wheel prevents itself from falling in the same way the globe prevented the clone from falling in my example. Now, when it's not moving, it will fall. But when it is moving, it will not fall. When the wheel is standing perfectly still, any object that causes it to fall out of balance will cause it to fall over. This can be the wind, the rider's center of gravity, or countless other things. However, this does not happen when the wheel is spinning. It is able to prevent itself from falling. This happens because when the wheel is still, a force like this is not only pushing the top that way, but simultaneously the bottom this way. These forces happen opposite from each other. So if it happens in the side, force this way is affecting that, and that is affecting that. But when the wheel is spinning, these forces have inertia. And so when it falls this way, that force is still happening when it reaches down here, and that force going this way will push this in the opposite direction. And so they cancel each other out. And the same happens with down here. So if the force comes from this way and tries to push it this way, it's spinning while that happens, and so it'll reach the top, and then it cancels out what happened on the bottom, causing the wheel to not fall over. The same gyroscopic effect and maintaining of angular momentum can describe how the bike can turn. Now, you would know if you've ever ridden a bicycle that turning this handlebars is not the only way to make the bike turn. As a matter of fact, a lot of it comes from leaning, especially if you're riding a unicycle where it all comes from leaning. So when you're riding a bike and you begin to lean, or a unicycle or anything, you're above this wheel, and you begin to lean. Your center of gravity goes from being right in the middle to on whichever side you lean to. So let's say you lean to your left. Your center of gravity is over here. So now you're having a force which is pushing this wheel this way. Now if the wheel is standing still and you lean, you're going to fall over. But when it's spinning, because it's maintaining the momentum, and this force has its own inertia, this force is going to keep going even after it spins. It's not going to stop as soon as the wheel turns 1 degree. That force doesn't go away. That force keeps going in this direction. So it's still pushing it when it's down here, which causes the wheel to spin. The same effect will happen regardless of the direction the wheel is spinning or the way you lean. So let's say, for example, that you lean to this side, you lean to the right, and the wheel is spinning backwards. So now you're trying to make it fall this way by leaning. But as it spins, it will catch itself down here, and that same force will keep pushing through, turning it this way. Now, as you can see, this is not actually perfectly, the two sides are not parallel in this cap. So it naturally wants to fall that way. And if it's flipped, then it will want to fall the other way. So you can see this demonstrated as it wants to fall this way. When it spins this way, it's going to catch itself in its fall and turn to the left. And that will happen every time. And if I flip it around, it'll try to turn to the right. All of these effects can be seen in this famous example of a gyroscope, which is a wheel hanging by a string. Now, since all the weight is on this side of the wheel, it wants to fall over. Gravity is trying to push the top this way and the bottom that way. So when you let go of it while it is not moving, it will fall. However, thanks to its maintaining its own angular momentum and the gyroscopic effect, when spinning, it will stay standing up. You may notice that the wheel is not only spinning around the axis backwards, but also spinning clockwise around the rope. Now the reason it does that is the same way that you turn when you lean on a bicycle or unicycle. Because all the weight is on this side, the gravitational force is pushing the top this side and the bottom this way. However, as it spins, the gravitational force is unable to push it this way due to the gyroscopic effect. But when it gets down to here, that force is still acting upon it. The force doesn't go away immediately. And so when it's here, it's still pushing this, but now it's pushing it this way. So when it is spun, it's clockwise around the rope.